All right, you guys, we are live. It's Wednesday. I think it's the 18th, 2020. I'm pretty sure it's a Wednesday, and we're still in isolation. So anyway, let's talk about the lesson. So yesterday we did substitution. And let me give a real quick example, and we won't do it, but yesterday we had something like this. If we had a y equals a 10 minus 2x, and if we had an x equals a y minus 4, a couple of things that's really nice about this is, one, we have y by itself. It says y equals 10 minus 2x. So we could either put the 10 minus 2x right in there. That's kind of nice. We put that right in there. Or we have an x equals a y minus 4, which means then, or you could put the y minus 4 right in for x. So here's the key. In substitution problems, you already have y solved for, y equals, or you already have x solved for. And these aren't too bad. We can do these. We did these yesterday. We set them apart, we substitute, and we solve. Okay, now, today is a little different because today we don't have y or x by itself. So let me give you an example, okay? So example 1 that I want to look at is this. I have 5x plus y equals 2, and I have a 3x plus y equals 7, okay? Well, bummer. It doesn't say y equals. It doesn't say x equals. It's all squished together. So here's what I want to do. Let's write them again separate. So equation 1, I'll call this one equation 1, I'll call this equation 2. And I'm going to do the same thing. I like to write them side by side. So I'm going to go equation 1, 5x plus y equals 2, and equation 2, 3x plus y equals 7. Now I'm going to put a little line down between so I can keep them separate. Now what I'd like to do is solve for either y or x. I always take the easiest one. So right here, look at this. If I were to bring the 5x over to the other side, then all that'd be left would be y. I'd have a y equals, and I could plug it in over here. Okay, I'll say it again. I want to get, so I have just y, so I bring the 5x over. So it says just y equals, and then once I get that y equals, I'll plug it into here. So let's do that. So how to bring the 5x over? Well, I've got a subtractor. So I'm going to go minus 5x minus 5x. And by doing that, of course, that's gone, and it brings it over. So I get a y equals a 2 minus a 5x. Can't subtract those. That's an x, and that's a number. That's a whole number. You can't subtract them. Those are different. But here's what I want to do now. I'm going to take this 2 minus 5x, and I'm going to substitute it in for y. Here's y. So I'm going to take my 2 minus 5x and substitute it. So now it becomes the same process that we did before. All right, so I'm going to go ahead and solve it. I'll rewrite this as a 3x plus, not y, but what y is equal to, which is a 2 minus 5x equals 7. Now I don't need the parentheses, but I put them in anyway just to show that it went in for y. I don't need the parentheses, but I like to put it because of this 2 minus 5x went right in there for y. Okay. Now let me simplify. Again, I don't need the parentheses because there's like an invisible one. So I got a 3x plus a 2 minus a 5x equals 7. I will combine the x's because those are the same. I got a 3x and a negative 5y, or 5x, I'm sorry. I can put those together and get a negative 2x plus 2 equals 7. I'm going to keep solving. I'm going to go minus 2, minus 2. I get a negative 2x equals a 5. I will divide by negative 2, divide by negative 2. I'll get x equals negative 2.5. Okay, so there's one answer. But remember, these are a point. The answer has to be some x, comma, y. So here's what I have. In my answer, I have a negative 2.5 something. So to get the something, take my new negative 2.5, bring it, put it in for x, because it says x equals, let me make it look better x, says x equals negative 2.5, so I'm going to take my negative 2.5, put it for x. I'm going to rewrite this as y equals 2 minus 5 times 2.5. And if I try on my calculator, it should be a 7.5, but you can try it on your calculator if you're not sure. So 5 times 2.5 is a, oh, I'm glad I checked. It's a 12.5. Wow, almost made another mistake, huh? So I've got a y equals, oh, that's a negative. Almost made another mistake. So negative times negative, double negative makes positive. I get a positive 2 plus a 12.5. If I add those, I get y equals a 14.5, and that's my corresponding y value. Okay? So, here's my answer. Circle it. So again, I used substitution, but I had to get one of the two by itself in order to solve. Okay? And I like doing it algebraically, because remember, this is like just a real quick review. We are basically looking at two lines that are graphed, and if they intersect kind of in a funny spot, right, we could actually get the exact answer. That's not a very good example of that, but anyway. Okay, moving on. Let's take a look at the next example. Okay, so I want to do another one of these. Okay, so next example. Let's take a look at, for instance, oh, I think I want to look at this one right here. Okay, example. I want to look at this one. Example. Example 2. Okay, I have an x plus y equals 3, and I have a 2x plus 4y equals 8. Okay, go ahead and write those down. So again, what I want to do is find the value of x and the value of y. So to do that, what I'm going to do is, again, I like to write them side by side. I'm going to call this equation 1, equation 2. So equation 1, I'll have x plus y equals 3, and I'll have a 2x plus 4y equals 8. Okay. So, same thing. I want either this one to say y equals blah blah blah, or even x equals blah blah blah. It doesn't really matter, but I need to solve for either x or y. I could do the same thing over here, but this seems like it's kind of like takes more work. I want to take the easier one. So let's solve for, say, y on this one. So again, we're trying to bring over my x. So bring over my x. In order to do that, I'm going to subtract my x, minus x, which gets rid of my x. It's gone. Of y equals 3 minus x, and I can't subtract those because that's next, and that's a, so now I'm going to substitute. That's a 3 and that's next, so now I'm going to substitute. I'm going to take this 3 minus x, plug it in for y. So take it right there and plug it in right for y, okay? So instead of writing y, instead of writing y right here, right, 3 minus x. So let's go ahead. Let's take a look at this equation. It still is a 2x plus 4, 2x plus 4, but instead of writing the y, I'm going to put my 3 minus x into it, equals 8, okay? So all I did is I rewrote this equation, 2x plus 4, but I didn't write y, but I wrote what y was equal to, okay? Now, I need to simplify, so let's distribute. So I'll have a 2x plus 4 times 3 is 12. 4 times a negative x, a negative 4x equals 8. Okay? So far, so good. 2x minus 4x, it's going to be a negative 2x plus 12 equals 8. Okay? And then, the next thing I'm going to do is keep solving for x. I'm going to go minus 12. I'll have a negative 2x equals a negative 4, because 8 minus 12 is negative 4. Divide by negative 2. Divide by negative 2. I'm going to get x equals positive 2. Okay, great. I've got my answer. So remember, my answer is x comma, y. So I have 2, comma, something. I don't know what the something is, but I'm going to find that out real quick. I'm going to take and plug my 2 right up into here for x. So plug that into here. So let's write in x. Let's write 2. So I'm going to go y equals 3 minus 2. Because instead of writing x, let's write what x is equal to, which is 2. Well, 3 minus 2 is just 1. So I have my answer. Okay. Now, let's take a look at the homework today, and there's one story problem. So the homework is going to be still 5.2. So the homework is still 5.2, but today I want you to do 10 through 19 all, okay? Homework is 5.2, so we'll call this 5.2b because it's second down 5.2. And we do 10 through 19 all. Now, when I take a look at it, on 10 I would have to solve for either x or y. On 11, I can just substitute. On 13, I'd have to solve for either x or y. Probably easier to solve for y in this example by bringing the y over. 13, to solve for x and y, probably easier to solve for the y right here. Bring the y over. 14, I can set them equal because they both equal y. 15 is going to take a little bit of work. I would probably solve for maybe y here. It's going to be, 15 is a little bit harder. 15 is probably the hardest one. I'll put a star there. That's the hard one. 16 is easy. Y is already solved for. 17, I bring over the 5 and solve for y here. Be the easiest. 18 is going to be a little bit harder. I'd probably solve for your y right here, and it's going to take a little bit of work. Okay, now 19. I wanted to show 19. Okay, an adult ticket to a museum costs 3 more than a children's ticket. So I set it up. Adult. So again, adult ticket to a museum costs 3 more. So adult is equal to 3 more than a child. Okay. When 200 tickets are sold, and 100 tickets are sold, the total revenue is 2,100. So I set up a second equation. I went 200 adults plus 100 children gives me a revenue of 2,100. What's the cost of a children's ticket? So you can do a substitution. I'd let you set it up there. Substitute this in for A, and you can solve for it, and hopefully you'll get the answer. Okay. All right. When I finally get my act together, I will show answers to all of these, possibly by tomorrow. I'm still trying to get my technology set up. So good luck. If you have any questions, give me a text or an email, and then we're going to keep moving forward. Thank you.